everyone. I'm Professor Wang from the Kunsan University in the southern North Taiwan. Today we will present the software-defined networking, in short, that's SDN, the Module 11. In this module, the important issue will be discussed. The issue 1 is the software-defined network. What's the SDN? The design purpose and its future, and some functionality. And we also discussed what's the problem and the limitation of the existing SDN system. The issue 2, we will discuss the application of the SDN as well. Initially, what is SDN system? To enhance the network security management, use the new flow management technique, some microsystem. Propose a new software control, flow control for network management in 1995. The SDN provides the network layer security service, such as the packet routing, flow control, identity authentication, privacy protection, and automatic security management through the decoupling the network control and the data forward function. In this diagram, they show that the flow forward using the S-flow agent switch. It can transfer flow from the different subnet. In this diagram, show that the IoTs, the networking, and through the open flow based gateway, and it controlled by the S-flow collector and controller. SDN controller is the central of the part of the SDN system. Then he will transfer the flow to flow aligner. The S-flow aligner performs the mission of the data analysis and the threat detection. If he detects some malicious attack, he will notify and send an alert message to the S-flow collector and to block or start this connection. If check is the secured channel and link, he can to connect to application. So effective defensive mechanism for the SDN security application to involve the data analysis and threat detection are required for the detecting intruder attack. The SDN command associated with the open flow protocol. Here, the switch and some device must be equipped with the open flow agent that run the open flow protocol for the network management. This is SDN's architecture. 3 layers. The bottom layer is the data forward layer. It is supported by the network devices open flow switch. To assist the device, the phone a link controlled by the control plane. The control plane, the center is SDN controller. He used the southbound, the API, to link the path. Then, if the data to attach to the service application, he will pass through the northbound and to connect to a specific application. So, from the hierarchical, the framework of SDN is the application layer, control layer, and the data forward layer. His is a centralized architecture for the network management that enable the dynamic programmatically and efficient network configuration in order to improve the network performance and for monitoring. This is a high-level overview of the SDN architecture. Let's move the focus to the SDN security, because the centralized architecture of the SDN system. So, control plane sees the botnet. He formed the botnet and also be attacked by the hackers. If a hacker, he compromised a switch in the data forward plane, this attack vector can be formed to the SDN controller and connect to the application. This is the step-by-step to describe how the SDN thread is attack vector. And this attack vector of the SDN system undermines the security of the entire network. If the SDN control the failure, that's formed a big problem because it's a centralized control. So SDN can provide an efficient network management, but also it can to generate some security warrior as well. The new development trend of the SDN technology now available for industry control application that require extremely fast failover. In some industry, you need a fast failover to conquer the problem of the system down. And some system cannot down. You know, that's the nuclear or the MRT system, or even to the airplane control system. So industry have to provide a more robust and reliable system, and the SDN can to play the role of industry control application. And one company and lost 100 faster failover for mission critical process, and the research on SDN and used some emulator as development for the research purpose. Is the SDN emu or the mininet. I used this tool to simulate some SDN system before you control the physical system. You can to run some simulation and to know some weak point of the SDN. Network flow control analysis. The implementation of the SDN control plane to follow a centralized hierarchical and decentralized design. It's a hierarchical and 3-layer and decentralized as possible. While this the simplified implementation of the control logic, it has the scalability limitation as the size and dynamic of the network increasing. When the network is expanded, the SDN maybe become a bottleneck of the float. So it's a challenging work to control the real-time float and to real-time analysis for the malicious connection. Possible problem of SDN development. SDN a centralized architecture produced not the numerical network float and the network lock, security lock, because of the increased connection with the network device. In practice, the SDN controller must collect and classify a large amount of the security lock immediately and to analyze the possible threat sources and influence the subnet. Consequently, the SDN controller becomes the threat bottleneck, thereby restricting the system scalability. So, have to solve this problem, and SDN the new development. So SDN architecture maybe enable, facilitate, or enhance network-related security application due to the controller's central view of the network and its capacity to reprogram the data plan at any time. While security SDN architecture itself may name an open question that already been studied a couple of times in the research community. The second issue, we will present the application of SDN. We search some online data. We find that the security application view on SDN controller with different aims in mind. For example, distributed denial service detection, migration, bonnet, worm propagation. The detection can be found in some research. Another kind of the security application leverage the SDN controller by implementing moving target defense algorithm. This is a new development system. We in short call the MTD. The MTD, the design purpose is to make any attack on the given system more difficult than usually, and he through the hiding or changing key property of that system of the network, so it can not easy to detect. Play the low like the intrusion detection system. He cannot to capture his IP. Okay. So SDN controller applications are mostly deployed in a large scale scenario that require the comprehensive check of the possible programming error. The new development of the wireless network, the SDN has to incorporate mobile the technique. Have a new development program that's called software-defined mobile networking, SDMM. It's a new approach to design of the mobile network, where all protocol-specific features are implemented in the software and maximized in the use of the generic and the commodity hardware and software in both of the core network or the radio access network. It has been proposed as the extension of SDN paradigm to incorporate the mobile network specific functionality. These another cases is the security, the monitoring. He used the nodes as the SDN controller and to monitor some IoT network and use the edge server to monitor based on the behavior of the future. This project monitored the flow among the SDN domain, several domains, and implemented the SDN controller framework with the event-driven Machinian network for the flow management. So the following the pictures that show us the typical architecture for SDN security monitoring. Application of the SDN system. This developed by our team. We use the S-Flow, the Machinian, the tool set, and to implement this system. This system uses the S-Flow aligner and to the specific traffic information from SDN controller, incorporating the S-Flow engine and the S-Flow collector. This flow engine in the data forward layer is the S-Flow switch and to connect all the agents to the SDN controller, and he collect by the S-Flow connector into the S-Flow MIB, that's the network management database, and pass through to the protocol aligner to find some anomalous in the connection, and to compare it in the signature database, and to find which is the thread, the connection, and to send an alert message to the firewall or the intrusion detection NIPS that to block it or to stop this connection. These are our references. Thank you, everyone. Bye-bye.